Hey everybody, today we're going to do a few more of the problems from the 2015 Mcas. This is the second session, so you're able to use the calculator if you have one nearby. There's also a reference guide at the end of the document you can use as well for formulas and such, which is right here. Okay, so we're going to see how far we can get. Bell's going to ring shortly, so I don't know how far we're going to get. We'll try to get a few problems though. Okay, so let's get right into it. Also, there's a PDF of this, so you should try this first before you watch the video. So Brandon plans to rent a truck. The cost to rent the truck is $30 for the first 4 hours, plus $10 for each additional hour. He can spend no more than $60. What is the maximum number of hours Brandon can rent the truck? Okay, so it's $30 for the first 4 hours. So first 4 hours go by, they've spent $30. Okay, we're told we have $60 total. Means you have 30 left after this, and it's 10 per hour after that. So if you go 3 more hours, you're going to spend another $30 because it's 10 per hour. Yeah. So 4 plus 3 is 7. This will be 7 hours. Number 31. A green can and a silver can are each in the shape of a right circular cylinder. The cans have the same radius, but the height of the green can is 3 times the height of the silver can. What is the ratio of the volume of the green can to the volume of the silver can? Okay, so first thing we need to do is know the volume of a right circular cylinder. So we're going to go ahead and look at our formula here. So right circular cylinder, we actually used this earlier in a previous problem. V equals pi r squared h. So V equals pi r squared h. Now we're not giving any of the actual dimensions. We're just told that they have the same radius, so r is the same, but the height's different. So height of the green can is 3 times the height of the silver can. So silver can we're going to call this one. And the green can is going to be 3 times that one. So it's going to be r squared times 3h. And that's the green can. What is the ratio of the volume of the green can to the ratio of the silver can? Let's just plug one in here. I think the easiest way to do this is actually just plug some numbers in here. So we're going to go ahead and give the radius, so I don't know, let's call that, make it real simple. We're going to call that 1, and h is going to be 2. R is 1, h is 2. Let's see what happens here. So I'm going to do the silver first. So silver, so pi times 1 squared, and the h is in this case going to be 2. So 1 times itself is 1. 1 times 2 is 2, so it's 2 pi. So that would be the volume of the silver can. Okay, now the green can would be pi times 1 squared times 3 times 2. Okay, so we're going to have pi times 1 times 3 times 2. 1 times 3 is 3, so pi times 3 times 2. It's going to be 6 pi. And that's the volume of the green can. So this looks like it's 3 to 1, because it's going to be, no, sorry, is it? Yeah, it's 3 to 1. So green to silver, so green is going to be 6 pi. Silver is going to be 2 pi, and the ratio would be 3 to 1. Should be D. All right, number 32 here. A student plotted point G, 9, 1 right here, and point H, 7, 3 here on a coordinate grid. The student will plot point F so that the midpoint of GF is point H. What will the point? Okay, so let me read that again. This could be confusing to some folks if they don't read this carefully. The student will plot point F so that the midpoint of GF is H. What will be the coordinates of point F? Okay, so here's the deal. They're essentially telling us that this is the midpoint of G and F. We don't know where F is. F is somewhere down here. There's actually a problem on the next generation MCAS that's very similar to this. The way this is worded can be kind of confusing. So we know this is the midpoint. There's a few ways to do this. You could use the midpoint formula, where you take the x values of both x1 plus x2 over 2, and y1 plus y2 over 2 is equal to the midpoint coordinates. You could do it that way because you have the midpoint coordinates. So you could solve for the x and the y of this, but there's a much easier way to do this since you're given the grid. So we're going to go ahead and calculate the rate of change here. So we went 1, 2 this way, so horizontal change of 1, then 1, 2, 3, 4 this way. So it's 4 and 2. So if I go 4 down and left 2, that should bring us to point F. Let's go 1, 2, 3, 4, and then 1, 2. So that should be point F. So 1, 2, 3, 4, 1, 2. That should be right where it is, which is 5, 7. Sorry, 5, negative 7. And like I said before, if you wanted to, you could say, okay, well, this is 9, 1, this is 7, negative 3, and you could use this formula, but it's a lot easier doing it this way. Okay, so 5, negative 7. We'll try to finish this page before we run out of time. See what we can do. The box in which you plot below shows the distribution of the times in seconds that members of a soccer team took to run one lap around a field. Okay, based on the box whisker plot, within which time interval did 50% of the members of the soccer team most likely run one lap around the field? So let's see what we have here. So 50% of the members of the soccer team is right here, because each of this is, so this would be 25%, this is 25, this is 25, this is 25. Okay, this is right in the middle here. So this is the middle 50%. So from 35 to 45, which we have right here. That's the interval right there. Number 34, what is the slope of the line represented by the equation below? So this is in standard form. We need to make it look like this. So we're going to get y by itself. So we're going to subtract 4x from both sides. We're going to have 5y equals negative 4x plus 10. And then we want to get the variable by itself, so we're going to divide by a coefficient, which is 5. And we're going to get y equals negative 4/5 x plus 2. So it's asking us for the slope or the rate of change, which is right here. So negative 4/5 is B. Okay, last one. The diagram below shows triangle LMN, right here, and its image, triangle RST. So this is a pre-image, that's the image, so we've done something to it, we've transformed it in some way. After a series of transformations in the coordinate plane, okay, what is the length in units of RT? So, okay, interesting. So a triangle LMN is going to be congruent to triangle, try the order here, RST. And it's asking us for the length of RT, this length right here. Now, you can't figure it out by using distance formula because we don't know its actual coordinates. Because whatever they did to it, it's not on a grid, so we can't do it that way. But we know that it's been transformed, which means these are congruent images. Okay, because I'm assuming they didn't use a dilation because they would have told us that. All right, so RT is the first and last letter here. Actually, different color here. RT is going to be congruent to LN. So if we know the length of LN, we can tell you how far R is from T, or the length of RT. So LN is right here, and thankfully they're right on the grid, so we can just count. 1, 2, 3, 4. It's going to be 4. And that's it. All right, let's check our answers. I think we don't have time for, no, bells in the ring, so we'll save this video. We'll save number 36 for another video. All right, so let's go back here. So let's check our answers. Let's see, where are we? Okay. So starting with number 30. So 30 we had D. 30 is D. 31 we had, oh, I didn't circle it. 31 I had D. And 31 is D. 32 we had B. 32 we had B. 33 we had C. 33 we have C. 34 we have B. 34 is B. And 35 is C. 35 is C. Okay, so far so good. We're doing pretty well on this. So when we pick it back up in the next video, which will probably be tomorrow, we'll start off with the short answers. Thanks for watching, guys.